Salutations, mini mathematicians. We are working on more exponent rules, some slick tricks to help you simplify exponential expressions. So today we're going to be learning 3 more rules to simplify exponential expressions with power of a power, power of a product, and power of a quotient. So last time we looked at multiplying powers and dividing powers. And now what we're going to look at is if we have a power raised to a power, if we have a product raised to a power, or if we have a quotient raised to a power. So let's get started. Okay, so number 1, what I'd like you to do is I'd like you to think about which of these are equivalent to 2 to the 3rd power, all raised to the 4th power. So take a moment and pause the video and go ahead and see which ones do we think are equivalent. And you can go ahead and play the video when you're ready. Okay, so taking a look, which ones are equivalent? Well, let's first explore 2 to the 3rd, all raised to the 4th power. Well, remember, our base is the number that's being multiplied, and our exponent is how many times it's being multiplied. So we can look at 2 to the 3rd as our base and 4th as our exponent. So we're going to have 2 to the 3rd multiplied by itself 4 times. So when we do that, now we have a product of powers. And remember, what do we do when we're multiplying with the same base? We add our exponents. So how many total factors of 2 will we have if we have 2 to the 3rd to the 4th? Well, 3 plus 3 plus 3 plus 3 is 12. So let's think of a slick trick we could have done if we had 2 to the 3rd all to the 4th power. Well, this is 4 groups of 2 to the 3rd. And when we think about groups, we think about multiplying. So we can multiply the exponents, and it's 2 to the 12th. Excellent. Well, here's 2 to the 12th. I can just kind of draw an arrow for my explanation. Well, what else do we have? Well, we can think about 2 to the 12th as 2 times 2 times 2 times 2, 1, 2, 3, 4, 1, 2, 3, 4, and another 4, 1, 2, 3, 4. Okay, so because we have 2 to the 12th, notice we can break this up into 3 groups of 4. And that's the same thing as 2 to the 4th times 2 to the 4th times 2 to the 4th. And 2 to the 4th is 4 times 4, which is 16. So this is 16 times 16 times 16, which is also 16 to the 3rd power. Nice job there. And if we grab our calculator, we can put in 2 to the 12th, 2 caret 12, and we get 4,096, and that's D. We can write calculator. And let's think about this. Well, if this is 2 to the 12th, 2 to the 7th, it's not going to be equivalent because this is only 7 factors of 2 and this is 12 factors of 2. So we're not going to select B. And what was their mistake? They added. They were thinking of our old rule. They must have gotten confused. 4 to the 4th times 2 to the 4th. Well, we can rewrite this 4 as 2 to the 2nd power to the 4th power times 2 to the 4th. Well, we just learned, thinking about this is a power raised to a power of a power. We multiply, so this is 2 to the 8th times 2 to the 4th, which then we can use our product of powers to add, and 8 plus 4 is also 12, so that's 2 to the 12th. So we know that A is also one of them. If we look at 6 to the 4th, well, I can't really rewrite 6 to be a power of 2. So you can just think of 6 to the 4th as 6 times 6 times 6 times 6, which we know is 36 times 36. And if you look at 36 times 36, it's 1,296. It's nowhere close to 4,000. So we know that our correct answer is A, D, E, and F are all equivalent. So what we need to think about is how do we find power of a power without expanding and use an example to justify our explanation. So to simplify, multiply the exponents and keep the same base. So here's an example. If you have 2 to the 8th raised to the 4th, that would equal 2 to the 32nd. Good thing I don't have to expand that out. Happy to use the slick trick there. Okay, so the algebraic rule for this is called, a little drum roll, power of a power. Power of a power. It always reminds me of playing Mario, and when he gets the mushroom and he like "Brr, brr, brr, brr," like powers up and gets all big. So that's what I think of. That's my visual when I see power of a power, like brr, 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 brr. Okay. So this states that x to the a power all raised to the b power is equal to x to the a times b power. Sometimes when I'm writing to make sure it's obvious that this a times b is an exponent, I like to put parentheses around it so it's clear and obvious that this is, yes, indeed an exponent. Okay, so we're going to look at this Venn diagram. So a Venn diagram compares things they have in common, things that are individual to these. So x squared all to the third, this is power of a power. Power of a power rule. And in this case, we would multiply the exponents. So we know this is x to the 2 times 3, which is x to the 6. Where this other expression, exponential expression, is a product of powers. And here we add the exponents. So we'd have x to the 2 plus 3, which ends up being x to the 5th. And what do they have in common? Well, they both have x square factor. It's a factor because it's one of the numbers being multiplied. You don't have to memorize the names of these, but it's helpful to be able to use them in explaining our simplifying steps. Okay, let's keep going. The next problem says to simplify x to the third power to the fourth and x to the third to the fourth power. Are the expressions equivalent? Why or why not? Well, we can simplify these and see. So let's see, x to the third to the fourth power is power of a power and simplifies to x to the 12th. X to the power of 3 to the 4th has a power as an exponent. So that's kind of funky, right? It's kind of weird. And simplifies to x to the, well, remember, 3 to the 4th power is 3 squared times 3 squared. 3 squared is 9, 3 squared is 9, 9 times 9, that's right, 81. X to the 81st power. And then remember, the question's asking me, are the expressions equivalent? So even though we did all that work, we haven't answered the question yet. Hence, no, x to the 12th is not equal to x to the 81st. I guess we could have said the original expressions. X to the 12th, which is x to the third to the fourth, is not equal to x to the 81st, which is x to the 3 to the 4th power. Much better answer. Okay, so let's practice our new rule. So looking at our new rule, we're going to practice 6 through 11. I'm going to help you with 7, 8, and 9, and you're going to do 6, 10, and 11 on your own. So taking a look at 7, we have power of a power of a power. So again, that's just multiplying. So you can start from the inside or the outside. It doesn't really matter. I'm going to start from the inside. So this is C5 times 6 is 30 to the 7th, and 7 times 3 is 21 times another 10 is C to the 210th power. Yay, slick tricks and not expanding. Okay, the next one, x to the n power all to the 2nd power. Remember, we just multiply our exponents, power of power. So this is x to the 2n power. We always want to write our answers in simplest form, which means coefficient in front of a variable, so x to the 2n power. Okay, and taking a look at 9, again, this is a raised to the n plus 1 power all to the 2nd power. This is going to be a to the 2 times n plus 1 power, and we want to simplify that completely. So it's a to the 2n plus 2 power. And sometimes I like to put parentheses around my exponent just to really be clear that yes, all that whole expression is in my exponent. Cool. Okay, go ahead and pause the video, finish 6, 10, and 11, and we'll go over the answers as soon as you're ready. Okay, number 6. Taking a look at number 6, we have a to the 3rd power to the 5th power, so a to the 15. We are multiplying our powers. Number 10, we had to do a little bit of simplifying and using some of our other slick tricks here. So the first thing I saw was b to the n to the 3rd power, power of power, n times 3 is 3n. Now I'm multiplying with the same base, so we add our exponents. So keep the base b, and then it's 3n plus 1, and 3n plus n is 4n. So b to the 4n plus 1 power is your final answer. And the last one, number 11, here we have power of a power, really similar to number 9. So we have r to the 2n plus 2, 2 times n is 2n, 2 times 1 is 2, times r to the n minus 2. Here we're multiplying with the same base, so we're going to add our exponents. So we end up with r to the 2n plus 2 plus n minus 2. When we simplify that all down, we get r to the 3n power. Nice job. Let's look at another rule. So our next rule we're going to be looking at is what happens if we have a product inside and an exponent on the outside. So this kind of is an expansion of our power of a power rule, but now we have a product inside. This only works if we have a product or a quotient on the inside, not if it's a sum or a difference. Okay, so choose all that apply. Go ahead and pause the video and select the ones that you believe are equivalent. Okay, let's explore. So if we look at 4a to the 3rd, all being raised to the 2nd power, what does that mean? Well, this exponent on the outside 2 tells me I'm multiplying 4a to the 3rd times 4a to the 3rd 2 times. And then I can organize this. So 4 times 4 times a to the 3rd times a to the 3rd. And 4 times 4, or 4 squared, is 16. And a to the 3rd times a to the 3rd, you add your exponents, we get a to the 6. So remember, this ends up being 16a to the 6. So if it's 16a to the 6, it's definitely not going to be 16a to the 5th. Their mistake is they added these exponents instead of multiplying. And it's definitely not going to be 8a to the 5th, because the 8, they must have done 4 times 2, not 4 squared. And it's definitely not going to be 4a to the 6th, because remember, that exponent of 2 belongs to a to the 3rd and the 4. Everything that's in those parentheses. Wonderful. So we're going to explain how to find the power product without expanding, and we're going to use an example, to, of course, to justify our explanation. So find the power of each factor inside the parentheses and multiply because they're all being multiplied. Okay, so an example, we could have 2x to the 7th all to the 3rd power. So 2 to the 3rd, 2 times 2 times 2, 2 times 2 is 4, times 2 again is 8. So this would be 8x to the 21st. So again, it's 2 to the 3rd power, x to the 7th to the 3rd power. Awesome. So let's look at another example. If you had, let's do 5x to the 4th all to the 2nd power. Remember, this exponent belongs to each factor on the inside. So it's 5 to the 2nd and x to the 4th to the 2nd. And that's 5 squared is 25 and x to the 4th to the 2nd. Multiply, power of a power, x to the 8th. Nice. So the algebraic rule for the power of a product, meaning you have everything being multiplied inside the parentheses and it's being raised to an exponent, states that a times b all in parentheses to the x power is equal to a to the x power and b to the x power. Notice I did not use the word distribute. We do not use the word distribute here. Distributing is multiplying to a sum or a difference. There's no adding or subtracting here. We can only use power of a product if all the terms on the inside are being multiplied or all the terms are being divided. Okay, let's apply our new rule to the next set of problems. I'm going to do 15, 17, and 19 with you, and you're going to do 16, 18, and 20 on your own. So taking a look at 15, power of a product. So we have a to the 5th and b to the 5th, and that's all we have to do. Okay, let's take a look at 17. So 17 here we have 2 to the 3rd times y to the 2nd to the 3rd times z, and you can always put to the 1st power there if that's helpful for you. You can also draw arrows to each of the factors if that's helpful for you. But remember, we are not using the word distribute. There's no distributing happening here. Okay, so we have to keep on simplifying. 2 to the 3rd is 8. Y to the 2nd to the 3rd power, we multiply. Y to the 6th and z to the 3rd. Coefficient in front and alphabetical order in the variables. Okay, let's take a look at 19. And I'd like you to put a star next to 19. You'll probably see this again in other important math questions. Hint, hint, wink, wink. Something's in my eye. So taking a look at 19, I'm going to work from the inside out. So I have negative d to the 2nd power. And what you can think about this as negative 1 times d to the 2nd power, all to the 10th, all to the 3rd. So if you work from the inside out, negative 1 to the 10th power is going to be 1. And then I have d to the 2nd to the 10th, which is going to get me d to the 20th. All to the 3rd is going to get me positive d to the 60th power. Even if you worked from the outside in, 3 times 10 power is 30. And then this negative 1 raised to an even power is going to be positive. So no matter what, 19 is going to be positive d to the 60th power. Awesome. Go ahead and finish 16, 18, and 20. Pause the video, finish 16, 18, and 20, and we'll go over your answers as soon as you're ready. Okay, let's see how we did. 16 is b to the 3rd power times 6. So here I have a to the 1st to the 6th power, b to the 3rd to the 6th. We have a to the 6th times b to the 18th. Alphabetical order is a must. Continuing here, number 18, again, we want to show our work and be organized. You could have simplified 3 to the 2nd as 9, but then you're just multiplying a bigger number later. So I kept it as 3 to the 2nd power, and I'm saying it's raised to the 4th power, x squared raised to the 4th power, y to the 1st raised to the 4th power, and z to the 2nd raised to the 4th power. 3 to the 8th, x to the 8th, y to the 4th, z to the 8th. And then I just continued simplifying and I used my calculator for 3 to the 8th power. Awesome. Okay, let's take a look at 20. 20 has a similar negative sign as 19, but notice it ends up being negative my final answer. So here you can think about this -1 and then a to the third because the negative a is not inside parentheses being raised to the third power here. So from here, I'm going to have -1 to the third and to the fifth power, a to the third and the fifth power, and b to the fourth to the third and the fifth power. You could have also multiplied the 3 and 5 and just raised all of these to the 15th power. No matter what, all those factors, you're always going to be raising -1 to an odd power. Since you're raising a negative to an odd power, your final product is negative. So we end up with negative, and then a to the 3, 3, 5, 3, 3, 3 times 3 is 9, and 9 times 5 is 45. 4 times 3 is 12, and 12 times 5 is 60. So this is our final answer, -a to the 45th power, b to the 60th. Notice no parentheses in my final answer, no multiplication dots. Awesome. Let's take a look at those fun equations. So we did these last lesson, and we're going to use exponent properties to solve for x. Well, really, we're going to use exponent properties to write a new equation and solve for x. So I'm going to help you with 23 and 24. You're going to do 21 and 22 on your own. So remember, the biggest thing we need to remember when we're doing these is we must have the same base to apply exponent. What do you guys want to call them? Exponent rules, exponent properties, exponent rules. Okay, so from here, what do we need to look at? We have 9 and we have 3. So this 9 we're going to rewrite with a base of 3 because I can't write 3 with a base of 9. It just isn't going to happen. So this is 3 squared. That's my 9, right? All to the x power, all to the 5th power is equal to 3 to the 20th power. Now we're going to use our power of a power. And we know we're multiplying. 2 times 5 is 10, times x is 10x. We have 3 to the 10x is equal to 3 to the 20. So now, since these are equal to each other, we know that 10x is equal to 20, which tells me x is equal to 2. Wunderbar. Very, very nice. Okay, so looking at 24, again, remember, we need to have the same base. So 4 doesn't match. So I'm going to rewrite 4 as 2 squared and just bring everything else down. So 2 to the 4th times 2 squared to the 6th equals 2 to the x plus 1 power. So from here, 2 to the 4th times, well, this is power over power, so that turns into 2 to the 12th, 2 to the x plus 1. And from here, I can use my product of powers, and I'm going to show my new equation, which is 4 plus 12 is equal to x plus 1. 4 plus 12 is 16 equals x plus 1. Subtract 1 from both sides, and x is equal to 15. Nice. Okay, pause the video, finish 21 and 22, and we'll check them as soon as you are ready. Okay, let's take a look. Number 21, taking a look at 21, I rewrote 25 to be 5 squared. So I had 5 squared to the x power, because before it was 25 to the x power. And now power of a power, 2 times x is 2x. So I know that 6 is equal to 2x. And divide both sides by 2, x is equal to 3. Good job. On 22, we know, looks like I crossed this out a little bit. We know we have 2 to the 3rd is equal to 8, still to the 2nd power. So if we look at this, this is going to be 2 to the 6 is equal to 2 to the x, because power over power. So here we know 3 times 2 is equal to x, or just x is equal to 6. Really nice work. Let's keep going. Okay, so the last page and our last rule we're going to be working on today is talking about a power of a quotient. So we're going to be looking at a power of a quotient, and we're going to think about how this simplifies. So because we have x to the fifth to the second power, that means we have x to the fifth times x to the fifth, because look up high, your exponent's how many times you multiply. Okay, and that's going to be x times x, 5 times 5, which we can call x squared and 5 squared. So this is x squared over 25. So remember, it says explain in words. Exponents are how many times you multiply. The exponent on the outside of the parentheses applies power of a power to all factors on the inside. So this includes all the factors in the numerator and all the factors in the denominator. So this rule is called power of a quotient. Power of a quotient. And that just means we have a fraction or a division problem and it's being raised up to a power. And it states that a over b all to the x power is a to the x over b to the x. So the exponent on the outside belongs to all the factors on the inside in the numerator and the denominator. Okay, so let's take a look. We're going to do 28, 29, and 30 together, and you're going to do the rest of the problems on your own. And this is where that organizing really comes in handy. You may want to think about simplifying everything on the inside first before you apply your exponent on the outside. It might help things out. So here, we're going to have 2 squared over 1, x to the third over x, and y squared over 1, all being squared. From here, I know that x to the third over x, this is a quotient of powers. So we have one factor that will cancel out of x in the denominator. My leftovers 2 will be in the numerator. So I have 2 squared, x squared, y squared, all being raised to the second power. So I have 2 squared times 2, exponent times 2, x squared, exponent times 2, y squared, exponent times 2. So 2 to the fourth, x to the fourth, y to the fourth. And remember our little fourth power trick, 2 squared times 2 squared is 2 to the fourth. So 2 squared is 4, 2 squared is 4. 4 times 4? 16. That's right. So our final answer here is 16, x to the fourth, y to the fourth. Excellent job. Okay, so taking a look at 29, very similarly, and you don't have to simplify what's on the inside first. You could apply that power of the 5 to everything on the inside, but since these are all a's, I'm just going to be dealing with smaller numbers to work with. Instead of 10, 20, and 40 as my exponents, I'm just dealing with 2, 4, and 8. So it's a little bit nicer. So the first thing I'm going to do is I'm going to see that exponent of 2 and 4. I'm going to add them to get a to the 6th power over a to the 8th power, all to the 5th power. So you don't want to do too many steps at once. You want to be following your work. So if you make a silly mistake, you can fix it later. Here you have 6 factors of a in the top, 8 factors of a on the bottom. 6 factors will cancel out, leaving you with 2 factors of a in the denominator. Or you can just think 8 minus 6 is 2 in the denominator. From here, this is going to be 1 to the 5th over a to the 2nd to the 5th. 1 to the 5th is 1. A to the 2nd to the 5th power is a to the 10th power. Give your final answer a circle or a box, or maybe some flair. Okay, so last one I'm doing with you, and then you'll have some time to practice. Again, this problem, I put a star next to 30. It's similar to ones you'll see on your test at the end of this module. I'm going to organize this first. So I'm going to bring all my coefficients, so 3 times 2 times 4. Remember, the reason we can move all these around is because the only operation happening is multiplication. And sometimes I'll like put a dot next to them so I don't lose a factor. I don't know, sometimes they just disappear. Okay, a to the 5th, a to the 4th, a to the 10th. So I got all those. Don't forget to the 5th power. Okay, so what do we have? We have 6 over 4. This is product of powers, so we add our exponents. We have a total of a to the 9th, 9 factors of a, 10 factors of a in the denominator, all still to the 5th power. From here, 6 over 4, hey, that's 3 over 2, scale down by 2. You have 9 factors of a in the numerator, 10 factors of a in the denominator. 9 factors cancel out. You have 1 left over in the denominator, all the 5th power. So from here, we're going to have 3 to the 5th power over 2 to the 5th power and a to the 5th power. So 3 to the 5th power, we can pretty easily do that, right? We can also, to the 5th power, if you wanted to, grab a calculator, 3 raised to the 5th power, 243. And in your denominator, 2 to the 5th power is 32. We also have that a to the 5th, and that's all in the denominator. So it's really important to show that that's all in the denominator, not making it look like that a to the 5th is in the numerator or next to it or something like that. And 243 and 32, they don't have any common factors, odd and even. Neither of them are divisible both by 3. Okay, so 27, 31, and 32, go ahead and finish up this lesson. Pause the video, and we'll go over our answers in just a moment. Okay, let's see how we did. Number 27, a little bit of a simpler problem than the one we did last together. 5 to the 2nd power is 25. X to the 4th to the 2nd power is x to the 8th power. Really nice job there. Taking a look at number 31, we have x squared to the n power and 4n to the n power. So we are using power of power to the numerator and the denominator. 2 times n is 2n, but n times n is n squared. So we have x to the 2n power over 4 to the n squared power. Really nice work there. And the last one, 32, taking a look here, we have a to the 3rd times b to the 2nd, all to the 5n. And it looks like I lost my exponent there. So I'm just going to do it with you really quickly. This is a to the 3rd. It looks like my work, I accidentally turned it to a 2. To the 5. Oh, you know why I turned it into a 2? You guys, I thought I made a mistake, but I didn't. This is a to the 3rd over a to the 1st, which, of course, the exponent of 3 and 1 with the same base cancel out, and we have a to the 2nd in the numerator. Silly, Mrs. Barr. Okay, so a to the 2nd, b to the 2nd, all to the 5n. So again, I decided to simplify on the inside first. So just make a little note about that. Okay, and then b to the 2nd to the 5n and b to the 2nd to the 5n, a to the 10n, b to the 10n. Notice my final answer doesn't have any multiplication dots or parentheses. Awesome. Great job, mini mathematicians. Thanks for doing your best and being nice to everyone. Stay psyched, and I will see you next time.